Welcome everyone to the Data Services Office Hour. I'm your host, Michelle De Palma, and I'm here with Daniel Parks. Not a surprise.
Hi, hello.
So talk to me about what we're going to do today.
So the idea for today is cover or try to cover a question that comes up quite a lot inside Red Hat and also from services and consulting about if we can deploy or if we can use Fiber Channel and iSCSI storage appliances to deploy ODF, to use them as the backing store for ODF. So it's a question that comes up quite a bit. So we can go through a little bit the recommended ways of actually doing that deployment, and then we also have a demo of one of the ways that is that we can follow just to give a guide on how to do it.
Perfect. Okay. So are you going to share the screen? You want to give me an overview of the details?
Yeah, I will. We can just have a chat about this in the beginning, and then we can go into the demo. It won't be too long, but just to give a little bit of context. So the idea is that really ODF, when we deploy OpenShift Data Foundation, as you know, Michelle, you normally just give it a storage class. So you will tell ODF, okay, here's your storage class. And ODF doesn't really care if that storage class is maybe a thin storage class provided by VMware, or like GP2 or GP3 in AWS. No, he will go ahead and use PVs from that storage class. So really, ODF is a consumer of the persistent volumes offered by OpenShift. Whatever is there, he's going to use, or whatever we select in the deployment in the UI. In that sense, another option that is perfectly fine for ODF is, for example, if you have a storage class that is offering storage that comes from a storage appliance using Fiber Channel or iSCSI, is also perfectly fine. There are certain things that we have to take in account when doing that kind of deployment for the configuration of how we have to configure the storage appliance and how ODF saves that appliance. For example, you have to take care about Multipath, that we will go deeper into that and what it is and how we can actually configure it. So certain things that we have to take in account, but in the end, it is supported and we can deploy ODF using iSCSI and Fiber Channel. Before going into the recommended ways of actually doing that deployment, what I also wanted to mention is a little bit like the benefits or drawbacks of when you deploy ODF, of using a storage appliance, a Fiber Channel appliance, or something of that kind, or going the other way, more the traditional way when deploying Ceph, that is maybe using like a bare metal node with just attach this to that bare metal node in the traditional way. So going back a little bit into when Ceph was designed, and the architecture was made for Ceph quite a long time ago. I think that's more than 10 years now that we have had Ceph around in the upstream project. So it has been quite a long time ago. It was always built since the beginning with resiliency of the data in mind. Data safety was always the first thing that was taken into account when designing the architecture. In that sense, if people have already played with ODF, we have to say, in any case, that the heart of ODF or the storage layer is Ceph. That's why we're speaking about Ceph now, because when you do an ODF deployment, you are going to get under the curtains or maybe transparently Ceph deployed on your OCP cluster, on your ODF cluster. So that's why we're speaking about Ceph. And as we mentioned, when you deploy Ceph in ODF, you're always going to get a pool with replication. By replication, what we mean is data safety, in the sense that if a user uploads a file or an object, that object is going to get replicated 3 times, 4 times, whatever we have configured in the replication that we have. By default in ODF is 3. Where that object gets stored, those 3 copies of the object, where it gets stored can be 3 hosts, depending on your configuration, maybe 3 racks, 3 availability zones. So then really it depends on your configuration. So as we are speaking, safety is clearly, or the safety of the data is really important with Ceph. And the thing is, if you have a storage appliance and you want to use it for ODF, Also, enterprise storage appliances have also data safety, so they also have replication. They may be using RAID 5, RAID 10, whatever kind of RAID they are using. No, they have also data safety in place. So the only thing that you have to take into account is that you are using an storage appliance, fiber channel, iSCSI, is that you are going to have the replica provided by Ceph, whatever is there, no, by default replica 3, and you also have the replication going on the storage appliance. This really translates that you are going to use, or you're going to need more raw storage, more total raw storage, because you are losing storage in the different places where you have replication. No? So that's one thing to take in account. No, that maybe you have too much data safety depending on the amount of the storage that you're actually using. That's one thing. And the other thing that I wanted to bring up is again, Ceph, no, when the architecture of Ceph is really built to be able to scale out, no, to a huge number of nodes. So being able to scale out without any bottlenecks. That's also like a fundamental part of the architecture in Ceph. That is very important for Ceph. So what you can do is really increase the number of nodes that you're using to very high numbers. And that's really possible because with Ceph, a client, when he wants to write an object or maybe read an object, he doesn't have to go through a controller, a storage controller, like you will go through in a traditional storage appliance, where you always have your one or two controllers, and every I/O that you do, every write, every read, has to ask the controller where's the metadata. So there's always a conversation going on there when he wants to access an object. And that's not the case with Ceph. No, with Ceph, you are able to now and then, or when there's an update, go to the monitor and get the monitor update, but that's just a very small query. And then the client by himself, using the thing that is called the crash map, is able to directly speak to the disks, not to the OSDs, and then he's able to start the data path and do all the IOPS that he needs. No? So that really provides an architecture that is able to scale to very big numbers.
Can I ask you a quick question?
Yeah.
So for the demo that we're going to talk and the best practice stuff that you're going to lay out now, we're always talking replica 3. We're not. I thought in one of the versions of ODF we could specify replica 2. Is that?
Yes.
Are you going to? So would you? My question would be, if a data engineer is sitting back and looking at just how many times they're actually replicating the data and the associated loss of storage volume because it has to be replicated so many times, like is anything that you're going to do today, is it always assuming that we're going to have Ceph doing replica 3? Do you see customers ever asking about, you know what, that's too much, that's too safe, too much data safety, let's go to replica 2, or I don't want to lose that much of my storage, my RAID array or whatever to replica or something like that. So, but just wondering if people are doing that or customers are doing that, and what are we going to see today? Is today basically all replica 3?
Yeah, so that's a very good point. So going into that we get that question quite a lot. No, and let's say that by default, let's say that the default pools that get deployed when you install ODF are replica 3. But what we do allow now is that, well, at least with internal ODF, because we can also have external ODF deployed, and then we will connect to an external Ceph cluster. No, but going into the standard internal deployment, there you always get a default pool that is replica 3. But you are allowed to create a new pool with replica 2 if you want. No, so the minimum that we support currently, outside of the default deployment and the default pool that goes with 3, is using replica 2. So somebody could go perfectly ahead and say, okay, I want to have a new pool with replica 2, and then I will configure a storage class pointing to that replica 2 pool, and you could have your developers, your applications also consume storage and only have replica 2. Okay. There is also work for replica 1, but replica 1 is really a little bit going against the architecture really of Ceph, but there's still work going on there. So because there are some applications, as you may know, like just an example, MongoDB, or there are many more, no, that have already a replication going on in the application. So if you add the replication on that you have on the application, then the one that you have in Ceph, and then if we also add the one that you have on the storage appliance, no, so we're losing a lot of steps of data. So there's work going on, and we're going to have news soon regarding ODF and Replication for this kind of use cases where let's say that the application is taking care of the safety of the data, not the replication.
Awesome.
So going into very quickly into the actual recommended ways. So when somebody, let's say somebody wants to deploy ODF, they already have an storage appliance, an enterprise storage appliance, and to use it because it's there, they have the storage and they want to make use of that. The recommended way that we suggest to follow is use the storage provider CSI driver. No? So each of these storage providers, and just condition, for example, Dell, but it could be each of them, no, have a CSI driver that will take care for you of deploying the CSI bits in all of the worker nodes. It will also take care of you of configuring the multipath that we're going to see afterwards in the demo how we do it manually, but it will do all of that work for you. And it will also, normally these CSI drivers are certified by the vendor, no, that you have the hardware with, that you're also going to get support for. If maybe you have an issue with the multipath in one of your workloads, you can always open a case with whatever vendor you have, and he will also give you support. So you are really going into a situation, going through that kind of deployment.
Okay, so just so we're clear, CSI driver, talk to your vendor, talk to your storage vendor.
Yes, because it really depends on the storage appliance. If, for example, you have, like we just mentioned in the example, Dell, then you want to use Dell CSI drivers, and you will deploy that operator, no, from Dell. And another thing that you get is because we normally deploy with an operator, you also get that is going to life cycle for you. So if there are updates on the driver, the updates are going to get automatically installed for you. So also day-to-day operation things are quite comfortable going through the approach of CSI drivers, and that's why if you use fiber channel or iSCSI appliances with ODF, that would be the recommended way. But as with anything, there are always edge cases, or there are situations where, for example, your storage provider doesn't have a CSI driver, or just a specific model, maybe it's a little bit an old model, and it doesn't have a CSI driver, so you can't go down that path. Then the next option that we can have, and that's what we're going to show today on the demo ourselves, and then we can use LSO, logical storage operator. That the logical storage operator is really an operator that makes use of a storage that's on your worker nodes. So that would work is that the storage team would manually present the LUNs, not from the storage appliance. By LUNs, I mean the drive to the worker nodes. They will take that. They would also configure the multipath. No, so once they see the disk, they will take care of configuring multipath. That we will just speak about it in a minute. And then they will install the logical storage operator. That logical storage operator is going to create persistent volumes, and those persistent volumes will be used in the end by ODF. No? So we can also deploy in that way. When we choose this kind of deployment, there are things, as we're going to see in the demo, that you have to take care for yourself. One is the multipath configuration in the core OS nodes. No? So in the worker nodes that we're going to use, that multipath configuration has to be done by you. And the other one is that this you're going to get when doing that deployment is from the OpenShift storage team, no? Because there's a team in charge of LSO, so they could have had an issue with the multipath. The only requirement that we have right now, if we want to go down this route, no, of using LSO with an storage appliance, fiber channel or iSCSI, is that we request opening a support exception to just let's say that the support exception is a way in which also Red Hat can see the configuration that you are doing, check that everything makes sense, all the options that are right, and that we won't have support if you go into production. No? So it's just double checking your configuration and everything is fine.
Okay, awesome.
Yeah, so that's more or less the introduction, and if you like, we can go into the demo. I will just share my screen a moment.
Are you going to do everything from
see.
scratch, or like the local storage, and then you can do multipath?
Yeah,
Okay, hang on a second. Let me share. There you go.
Yeah, there are certain things that I'm going to have to that I already have in place, and I will explain just in a moment. So the only thing that I wanted to show or to mention, just in case somebody hasn't heard of Multipath before, and that's why I have this image and this is explain a little bit why it is so important to actually configure Multipath. No, so with Multipath in Fiber Channel or iSCSI, what we are providing is different paths to the drives, to your storage appliance, to the disks that are going to be consumed by your server. No, so we are working with databases, with production applications. It's vital that never lose access to your I/O, no, to your drives. And Multipath provides availability and removing single points. And the example that we have in this diagram is simple. As you can see, we have a server that in our case would be like an OpenShift worker node that has two HBAs. By HBAs, it's just the interface that gives us access to the fiber channel. No? So the server has two HBAs. We also have two different SAN switches. No? So we have two different switches with different ports, and also the storage appliance has two different controllers. And what this provides us is that we could lose in our server an HBA. For example, with CI failure and you lose the full HBA, the server is going to be able to go through the other path and still have access to its data without even noticing. Maybe you have a small loss or blocking in your app, but the application is not even going to notice. It's just like a small interruption while the failover is going on if you're working with active passive. But you could also, for example, fail a full SAN switch, or maybe you're just doing like an upgrade to the firmware of your SAN switch and you need to very briefly switch off the SAN, or even if your controller, the ports on the controller and the actual fiber channel cables are quite delicate, so maybe one gets broken, you get an issue on your controller, you are still always going to be able to provide access to the storage through the other path. No? So that's why it's so important to have multipath configured, because if you don't use multipath and you go straight, even if you have two HBAs, but you only use one of them, then it doesn't matter how many HBAs you have. If you lose the path, you're going to lose access to your storage. No? So that's why it's important.
Okay.
And going into the demo, that was just to give a little bit of the layout that we are using. Let's say that the demo that we're going to use is just a lab, so I am not taking into account that this deployment is perfect or high available. So let's say that the deployment or something that would be more production ready would be something like this, no? Where each of our worker nodes, as we said, has two NICs, two interfaces, and each of them goes to a different switch. And also our storage appliance is connected to the switches, so everything is redundant. No? So you could support the failure of almost any of the components and you will still have access to the storage. But I'm going to the actual lab that we have that is a little bit simpler, because the main goal of what I want to show today is how to configure multipath and then how to use LSO to consume that multipath device that we have configured. So This is our demo, our diagram. What we have is 3 worker nodes that are going to be our storage nodes. And what we want to do is assign a LAN to each of them, no? Because this is what later on ODF is going to consume. A LAN really is a drive, and we're going to use a Red Hat Enterprise Linux. So this is really a RHEL 8 running on a virtual machine that we have already configured, and this has been configured as a iSCSI target server. So in this server, we have 3 100 gigs. We are going to map each of these LUNs to one of the servers. No? So this one is going to have access to LUNs 0, LUN 1, and LUN 2. No? So we're going to have, in total, 300 available for ODF in this example. Why are we going to have multipath? Because as you can see here, our enterprise Linux POC that we're using as a SCSI target has two NICs, no? Two interfaces connected to the switch. So these servers are going to see the storage through two different paths that we have here. And that's why we need to configure multipath. If we have time, at the end, we would also fail one of these NICs, and we will see how the storage keeps working without interruption. Okay. Is that more or less clear? Michelle, do you have any questions before we begin?
Yes. Okay. Can you flip back to the one that shows the HA pairs and everything? The other slide. Okay. Just to see, I just want to go make sure we go through the difference once again. So the worker storage ODF nodes only have one NIC in our case because we're in the lab. We only have one switch, but our switch has two controllers, and we're gonna, if we have time, we get to fail one over. The end result will show one LUN exposed to each matching, like LUN 0 will go to the one that you just like you have in your diagram. And okay, so that's perfect. I just wanted to make sure, like, just to go through it one more time. Okay, awesome.
Yeah,
right.
the good thing about this more production ready, let's say, now is that you have really two NICs in your worker nodes and you have two switches, so you are reducing single points of failure here. This is a single point of failure. Each of these NICs is a single point failure. The only thing that is really high available is the storage appliance. But it's good enough for our example because it's going to give us the chance of configuring multipath for both of these paths that we have here, for both of these NICs that we have.
Okay. All right, great.
Perfect. So let's go a little bit into the demo here. Here I just have, let me show you an OCP cluster. We have 3 master nodes and 3 worker nodes. Let me also go into one of these worker nodes. So we can also run commands from inside the worker node. So really what I'm doing here is that I'm going into the operated system node of one of the worker nodes that you can see here. This is a core OS. So I really have just logged into this one. So we will leave this ready. And then we can go from here. The other thing that I have ready in another, let me get a little bit bigger, is the iSCSI server that I showed you. This will be like the storage appliance, and I would just want to show you the configuration that we have here. I don't want to go into the details of the iSCSI configuration. It's really very simple because it's using open iSCSI that is available in RHEL, but I won't go too much into the details. The only thing that I wanted to mention so you can see is that we have this IQN that is really like a unique identifier for one of our worker nodes, and I will show you right now in the worker node how we can find out where it is. Mapped LUN 0. For the second worker node, we have LUN 2, and the first one, we have LUN 1. So really, just to show you the configuration, very similar to what we have here. I'm really mapping this LUN to this server, this one to this one. So we're doing a one-to-one relationship using the unique identifier that this is typical of iSCSI. And if we go here into iSCSI, this is our worker node that entered before. We have here the initiator name. I just want to show you that this name, let's just get the last node, 75E. As you see here, is this one. So really what we are doing is we are mapping to that worker node this LUN. That's the relationship that we're doing there. In any case, I wanted to mention before going on that I have like a document that I have in GitHub that we will share at the end with all of the steps that we have, even for configuring the iSCSI server, just in case someone wants to go through the full demo. I have all of the commands and all of the outputs. So if someone wants to later on give it a test or maybe go a little bit slower and do the demo, we are going to share that at the end. Okay, so let me show you then Well,
Okay, that
let's
font's
do
really
it.
small. Just letting you know.
Yeah, yeah. This is just for getting the command. I'm not going to. I'm not going to run anything from there. So what I have already done is I have from the worker nodes. So all of my worker nodes have already logged in to the iSCSI target, to the iSCSI storage appliance, and they are already seeing the LANs that are configured. So what you can see from this command, that is the iSCSI ADM command, is that I'm seeing through two different paths. That is what is called the portal here, that you can see that there's two different IPs, 100 and 101. I am seeing LAN 0. That is what we have configured here, as you can remember. No, we just mentioned that we have LAN 0. So what we are checking right now is that it's actually working. The configuration that we have done is perfectly fine. The thing is, an important thing to note is that you can see here that this is called disk SDB, it's a SCSI disk, and SDC. So the important thing to take here is that the operating system, the Linux operating system, is going to show you each path to the storage as a disk. And let me also show it here with LSBLK. So as you can see here, we have SDB and SDC of 100 gigabit. What's the biggest mistake? If you go ahead and, for example, you will say, okay, I want to use ODF with SDC, then you are not using Multipath because you are directly going through one of the paths. Only we have to do, and why we need Multipath, is that we are going to configure a virtual Multipath device on top of the paths that we have. So really, we don't want to use SDB, we don't want to use DC, we want to use a multipath device when we actually configure LSO and ODF. That's the important thing to take into account. So that's the thing that is a little bit confusing, and that can take you to an error. Is just going ahead and using these two disks. This disk, if you run a command on this disk, it's just exactly the same as this one, because as you can see here, the backend for both of these drives is LAN 0. It's just a path to each of a different path to the same disk. Okay, so what we want to do now, as we just mentioned, is configure multipath. So we actually have that virtual device mapper ready to be configured by LSO. So let me just also show it from here. So this is really not dependent on CoreOS. This comes from Rail, from Linux in general. When you want to deploy multipath or you want to configure multipath, you have to use a multipath.conf file. The one that I have here is just an example. It's almost a default example, with the defaults, user-friendly name. So I really won't go into the options, because what normally happens is that the storage provider that you are using is going to recommend you multipath options that you should set in this file. So if, for example, you're using HP and a certain storage appliance from HP will have one or two different options. Then you could go to Dell, to whatever storage provider, they are going to recommend you what to set in this file. That's why we're just using a very basic default, and just take into account that you should ask your storage provider what to set in the multipath.conf to get the optimal connection or configuration in your case. So, okay, we can say we have the multipath.conf file. How do we configure it in our worker nodes? We have our 3 OpenShift worker nodes. How do we configure that conf file? From OpenShift 4, the thing that we normally recommend is that you don't make modifications on the operating system. So don't go here, for example, into this node and then use VI and do a modification into the file or change whatever, because those, once you do an upgrade, once you do a modification, are going to be lost. So they're not permanent there. So the recommended way on doing modifications to configuration file CoreOS worker nodes in NOC is using what is called the matching config and the matching config operator. The matching config is really an object that is going to take care of implementing whatever changes or whatever files you want to introduce into your operating system. So it's going to really take care of having the same configuration files on all of your worker nodes, so there's really no drift between them. If you make a change in one of them, it's going to take care of always having the same configuration on all of them. No? So that's why you have the matching config object and why it's so nice and easy to use. The good thing using the matching config operator and the matching config object is that it will roll out the changes in a rolling up fashion. What I mean by that is that it will go node by node, upgrading or making the modifications that you have implied in your declarative YAML file, and it will take care of cordoning the node, draining all the pods, and then making the changes and rebooting that worker node. And then it will go into the next one. It will make sure that everything is running, and they will go into the next one. No? So it really takes care of all our pods and that we don't lose any, we don't have any application downtime while we make these changes.
Are you going to show us how to do that now? Like we'll actually see how you make these changes. And I was just going to ask you, but don't we need certain things to be specific to the node? Does the machine config operator handle specialty? Like one's going to go to LUN 0, one's going to go to LUN 1. Just they're not 100% identical, right? Okay.
So the configuration with multipath.com. So the good thing is that the modifications that we have to make are not specific per node. So the only configurations, as you can see here, that we want to implement are really these ones, and this is generic for all of them. If you have specific cases, you can also do matching config per node, but then it loses a little bit of space because you have to go specifying or making profiles for each node or pools for each node. That is a little bit an inconvenience. But what normally happens if you use MCP, that this is machine config pool, you can see here that we have two pools, no, for our masters and our workers. But you could make more pools. This is configurable. So, for example, you could have a new pool that is called nodes or storage nodes or whatever. Right. Yeah. And then the changes would only be applied to those nodes. Here we're doing a simplified configuration, and we're only going to make modifications to the MCP related to the worker nodes.
Okay.
So let me just clear this out, and what I will do is just a second, because this takes a while. Let me apply the file, and then we can just cover a little bit what we have in the file. Okay, so we said we have a machine config object. We are going to apply only worker nodes that, so the role is worker that we just mentioned before, no? So we are only going to apply these changes to all of the machines that are considered workers. This is the name that for a machine config that I will show you in a moment. And the first thing that we want to add is a file. No, we want to add the multipath.com file that I just showed you a moment ago. How do we pass the contents of the file? Because this is using Ignition. That Ignition is also from CoreOS, and it's a way that we use an OCP for deploy configuration of the OCP nodes. It really uses base 64. So what you're seeing here, this stream is really the multipath.com file. The only thing that is in base 64.
Okay.
So as you can see, this is exactly here. No, I have just run this command, this part here. That's how the Ignition files are passed. Not that we have to make this easier, and that will come this change for you, so you don't have to really be involved. This has really improved a lot the user experience. No, but just for this simple example, just so you know that here is our file, and it's going to be placed in all of the worker nodes in this path. And then we are also enabling these different systemd units. So we are really making sure that if we reboot the core server, we are going to be able to run iSCSI D, you know, that we need for the connection, and also multipath D. Okay, so this is our machine. If we now do an MC, what we can see here is that the worker nodes, we have a new rendered config. the matching config daemon on each worker node has detected that there's a new hash, there's a new version, and then it has started updating the nodes. As you can see here, it says updated true, no? So the update taking place,
Okay.
and it has already done one machine. Here you can see that we have 3 and 1 is already ready. One already has the new version. And if we do OC get nodes, you will actually one of this scheduling disabled. This is the one where the updates are happening right now. So as we said, it will go one by one, doing the upgrade of the different. While this is going on, what we can take care of just to move forward is actually installing the LSO operator. So this is the UI of the cluster that I just showed you before. And let's just install the local volume operator that we have here, local storage. This is version 4.10. This is just a normal procedure, no? When you would normally deploy the LSO operator. This is just the operator, it's not the actual operator, so we're not in any configuration. This is just to get it ready.
Okay.
Another one that we can also deploy to move a little bit forward while the updates are going on is actually ODF. No? We can do here data foundation, and we can also leave this version 4.10.4. Let me make this a little bit bigger also. And we can also leave this deploying. We could deploy the operators via the CLI. I'm just following the UI way, no, of deploying the operators. That's why these are going on here.
Did the machines
so
finish?
we can see now.
Okay.
We have two. So we're just missing
More. Okay.
We're just missing one. So let me go back to my worker node. Well, let's go back to one of where the changes have already happened. No? So what I would really want to check now is that actually the multipath configuration is working okay on this node. So let me just very quickly run the command. There is command no multipath -ll, and you will the configuration of the multipath device. So what we have here is that now we have this virtual device mapper, virtual device or virtual disk that really is the one that we want to use to configure LSO. No? So when you want to reference a multipath drive that comes from Fiber Channel, that comes from iSCSI, you always have to use this name. And as you can see, what it has underneath is 2 paths to our storage appliance. We can see here that it's drive STC and STB. Because our storage appliance and what we're using is really active passive, what you can see here is that one path is active, the status is active, and the other one is just an A. So it's really waiting. In the case that this path fails, it will do a failover, and then the other one will be active. No? So it's ready to act if needed, if we have a failure here. Okay, so this is looking great. We have path A configured. Let's see if it finishes in all of the nodes. It should be getting there.
So the virtual device on each node is going to have the same name?
Yeah.
Even though the underlying disk will be different? Empath. Yeah. Okay.
Yeah, well, you're always going to, when you saw that in the configuration file, we used user-friendly names. If you go with user-friendly names, then it's going to call it empath A, C, D, no, in order as you add more drives. Okay, so let's just check that. Sorry, MCP. This is matching config, just to mention it, that we have here. This is the one that we have deployed. But what I wanted to check is that everything is updated. No? So as you can see here, the 3 worker nodes have been updated. Everything is looking fine. Empath, multipath. What we can do now is actually deploy LSO. So let me move to the LSO namespace and see if our operator is okay. So we can see here that our local everything is looking good. Next thing that we need to do is actually label our nodes. And now I will explain to you in a moment why. Let me just get the
I thought we were already
here.
I mean, we had the worker label. You're going to give them an additional label? Like, okay.
Yeah, let me run it here. Here I'm running the commands now. So yeah, so this label, and I'm sure that this will make sense now when I explain it. What we are adding is this label, the OpenShift storage label. And if you remember, when you deploy, if you do it through the UI, this gets automatically done for you, no? But if you're going through the CLI, you have to really use the label. So ODF nodes, which worker nodes are going to be your OpenShift storage node. So that's really what we are doing now with this label. So we are really not making it a worker. We are really saying, okay, I want to use this label to deploy ODF. And here we can see that both, well, the 3 of our worker nodes now have this label. Now that we can also do get nodes show labels, I think, and then just grab by the label that we have just set, and we should have 3. So as you can see, we have worker, 3 worker nodes now have this label. Okay, so what we want to do now is use a local volume YAML. So what I wanted to mention here is that when deploying ODF and using LSO, you can do everything when you're doing a normal deployment that you're not using Multipath. When you're not using Multipath, you maybe have so on a Permel node or on AWS or whatever. If you want to use LSO, you can just go through the UI, and the ODF UI will really guide you through, install the LSO operator for you, and then it will do all of the configuration of LSO for you. The thing to take into account is that when using Multipath, you can't use that standard approach, so you can't use the UI. If you want to use the Multipath, you have to use the local volume object that I'm showing you here now, the local volume. So normally what you will get with LSO is that you will normally just tell it, okay, go to these 3 nodes or to whatever nodes and scan all the storage that you have, and then you will set filters. No? So for example, I want to use all of the drives that are bigger gigs, or I want to use all of the drives from a model of Hitachi or whatever. So then it was really doing a lot of the work for you, because you don't have to go disk by disk, specifying I want to use this drive or the other drive. You just set generic filter, and it makes the deployment easier. That's when you go through the UI or when you use the discovery approach. That is the default now in LSO.
So just so I'm clear, so you're saying that, as I remember, LSO will go and do a little discovery, and then you put a filter on that discovery to see which ones you want. But in this case, because we have Empath A, which is virtual, we have to specify it. It won't discover it on its own?
That's right. That's right. So the current implementation will change in the future of LSO is not able to discover, let's say, multipath devices. It doesn't understand them, just to give an example. No? So really, we have to go and use this local volume approach and give it the specific device so it's able to consume it. Otherwise, the discovery side of things right now doesn't understand multipath devices. No, so that's the issue on why we can't use it. In the future, it will be implemented. But right now, if you want to go down this path of using storage appliances with multipath, you have to create this logical volume. So just let me just run it, and I will explain in a second what we have in the file. Okay, so in this file, what we are really setting is the local volume object, and what I'm telling it is all of the nodes that have this label. If you just remember a moment ago, we set this label in our worker node, so we are really telling it to all of the worker nodes that have this label and consume or use for LSO the device Empath A. That is our multipath device, and as we explained, that's the one that we want to use for ODF, and then we are telling it, with all of these devices that you find, create a storage called local block. So if everything is correctly, when this process of the local volume finishes, we will have a storage class called local block that we can use on our ODF deployment. So let's see if we have, okay, so this is perfect. Let me just also run with white so I can explain you here. So as you can see here, we have a maker pod for each of the different worker nodes. So really this maker pod, what is going is into our node and it's doing the configuration for that multipath device. If now I do, let me just do a clear so we can see it better. If I do persistent volume, as you can see, we have 3 system volumes available and they are 100 gigs. That, if you remember, is the size of the LANs that we have configured as appliance. And just to make sure that we are actually using the multipath device, that is very important. What you can do is, for example, here, I think, let's see if this works. Yeah, so what you can see here is that the path that we are using for this persistent volume is our mPath A, So that's perfect. It's exactly what we needed. And finally, we can just list the storage class for the storage classes that we have. And we now have a new storage class that is called local block, one that we want to pass to ODF. So let's go into ODF and now just follow deployment. We have done that part that I just showed. We have already done the hard work. Now really we just have to go into our installed operators. If you remember, I already installed ODF, the operator, and now we want to create a storage system. So we want to deploy. Here we are not going to do any modifications. We're going to do a full deployment. The difference is that the storage class that we are going to use is local block. So here I'm telling ODF, okay, go ahead and use my LSO devices that are actually our multipath devices from our storage appliance. And the rest is just the same. Here you can tell raw capacity is 300 gigs, which makes sense because we have drives of 100 gigs that I just mentioned before. So just go ahead. This is also asking if we want to use encryption. This is just to show that it actually deploys, so we can go ahead with all of the defaults. And now ODF is going to get deployed for us using the persistent volumes that we have created. This is normal when deploying ODF, so sometimes it just comes up. We can just go refresh the browser. And what I'm going to do is go into the namespace where it gets deployed, open shift, and let's see if this is going ahead. Okay, so as you can see, this is ODF getting deployed. So what is going to happen here, or should happen, is once the OSDs that are the ones that consume our drives, we should see that the persistent volume claims are no longer available and that are being used by ODF. This maybe will take a while.
Okay.
Yeah, it's still deploying. The other thing that we can move forward and do while this gets deployed is actually taking a look if we have the test application that I wanted to run. Another thing that I wanted to check, I don't know how we are doing on time, Michelle.
We have like
because
10,
I think that
10
we
minutes,
already,
but
yeah.
So
we can just went. I won't do the full demo with the application and everything because it's going to be too long. Just to mention, what I wanted to do is that we have like a test application that we would also leave that link so people can use it if they like the GitHub repo. But that application really what it does is that it does an IO or does certain IOs each second. So you can very easily see if you lose IO, you can very easily see that you have lost IO for certain seconds. And then what I wanted to do is just throw down one of the iSCSI paths and see how the IO wasn't, it was not interrupted, let's say, But we're not going to have time and maybe it's too long. But the only thing, I just want to wait until ODF is deployed so we can see that the actual PVs have been claimed.
Okay, so while this is deploying, so just to recap at a high level, because you mentioned that this is a question that you get from customers about how to configure it with Multipath. ODF is just from the ODF point of view, it's really it's another LSO configuration, right? Like that's
Yeah.
nothing really changes at the high level. Underneath LSO, you have to have the multipath configured. And a confusing point, at least when you were talking before, is that when you go into your worker nodes, you actually see both. You see what is really the same disk show up twice because you've got two paths to it, and you have to not use that and actually create the multipath disk properly. And you are doing that through the machine config so that it actually gets applied even the same way across each worker node. And we just went through the detailed steps to get there. But I'm just thinking of like, if as a customer thinking about this, like that's how you come in. ODF is basically the same. You're just going to choose the right storage class. Underneath that, you got to make sure LSO is using the virtual device that is the multipath device. And underneath that, you want to make sure your machine config has been configured properly so that you are using the correct disk and it sees it as one virtual disk. So, okay, multiple steps, trying to.
Yeah, that's perfect. Okay. The only small thing that they would add to what you have just said, that's perfect, is that you have to take into account that you can't use the UI for deploying LSO. That's the only thing, that you have to go with this local volume through the CLI. But otherwise, what you just mentioned is perfect. So really
do we have this in like the training docs, or is there a knowledge base doc that maybe I'll look for that after? And if there is one, I'll post it in the description just so that someone can see the steps laid out. Like, don't forget, can't use the UI and LSO at this step or something like that. So I bet you we have it as we might. Okay. Awesome.
Yes.
Sorry, go ahead.
There is like a knowledge base being written with a little bit with these instructions, so also customers have access to it and take into account these little details that we have now when we want to configure LSO. Right. In any case, again, the preferred route to go through, if possible, is with the CSI provider of the storage appliance. That's going to make it easier because all of the steps that I showed here today, you will just deploy that operator. The operator from the storage provider will do all the work for you, and then you will just deploy ODF normally, just pointing to the storage class that has been created by that operator. Right. And that's really easy. If you are in the case like we just showed here that you can't use that path, then you will have to follow these steps. That, as we mentioned before, we will have them with all of the details on the notes for the show, just in case someone wants to go through them and they can help. Okay, so just let me show you here if we have our SF cluster created successfully, health. And just the final thing that I wanted to do is remove one path. So what I'm going to do here is really I'm going to move one IP. Okay. And I just want to show you how this shows up in the multipath configuration. Multipath. I did an error moment that we need to open. This is just the final command. I just want to show you how now we have in our multipath configuration, but the iOS is still fine and everything is still working. We do here.
So we're going to see that the other one is active, right? Like we had one that was active and then one that was passive.
Let me just. I forgot here to actually apply the change now, because if you just run the CLI, now we have applied the change. And you'll see, as you mentioned, the paths, I don't know which one of them, but we should see one of these paths that have failed.
Right.
So as you can see here, the only thing that we failed, the passive one. So we see in the failover, just to show you that the path is faulty, but this one is still active. If you try to write to mPath A right now, the application will be, and let's say that CEF and ODF will be working perfectly without even noticing that you have had this issue. I wanted to show why it's so important really to use multipath. Here we have just dropped an interface, but this could be a switch, it could be anything in the path of the data, and that's why really it's so important to have multipath when you're using fiber channel and iSCSI storage appliances.
Okay, well, that was fantastic. Wow. So lots of detail. Maybe you want to refresh that screen. Oh, here we go. Lots of detail there. And we are definitely going to apply. I'll put some stuff in the description so that people can see step by step, maybe a knowledge base article. And we wanted to give the repo that has the application so you can see like writes being done, and then maybe you can fail one over and stuff like that. So that was a really wonderful. Thank you so much. As always, pleasure. So take care, everyone. Thanks.
Bye. Bye.